Hello students, today I will discuss about isothermal change. So what is isothermal change? At a constant temperature, the change in the pressure and volume of a gas is called isothermal change. So at a constant temperature, if we can cause the change in pressure and volume of a gas, then the change is called isothermal change. So it happens in two ways, isothermal expansion and isothermal compression. By these two ways, the isothermal change happens. So it is a very slow process. It happens in a very slow, taking a long time in a very slow process. If we take a diagram of isothermal change, so it follows Boyle's law, Pv is equal to constant, because temperature is constant. So we will get in this way. If we take a constant temperature T1, then we will get the diagram in this way. If we take the temperature T2, then we will get the diagram in this way. And if we take T3, we will get the diagram in this way. Here T1 greater than T2 greater than T3. So T1 is greater than T2, then T2, then T3. So now we can deduce that PV diagram, we can very easily look that PV diagram is a rectangular hyperbola. So what is isobaric process? So to know about the isothermal change, we have to deduce isobaric process. Here we will discuss the isobaric process. If we take a piston and here a gas is taken here in the piston, here the cross-sectional area of the piston is A and the expansion or compression of the gas along piston is X taken. So the force applied from the external source F is equal to PA, force multiplied the cross-sectional area. So the applied pressure P is equal to if the applied pressure P, then the applied force F is equal to P multiply A. So the work done by the gas is equal to F applied force and the expansion or compression of the gas along the piston. So is equal to, this will be F multiply X or PA X or P into dV, the change in the volume of the gas. So change in the volume of the gas. This is the change in the volume of the gas, dV. So here the work done by the gas is equal to P into cross dV. So dV is the change in the volume due to the applied force. Now we know that by first law of the thermodynamics, that Q is equal to du plus W, where Q is the supplied heat energy, W is the work done, and D is the change in the internal energy of the matter. So this is the law of the first law of the thermodynamics, Q is equal to du plus W. So here in the isothermal process T is constant, so we will get that internal energy, change in internal energy is equal to 0. So we will get Q is equal to W. So from this we can calculate the work done or the supplied heat energy by just taking just integrating this for a change in the volume. So we will get W is equal to, taking the change of the volume V1 to V2, P into dV. So we know that for the ideal gas of N molecule, PV is equal to nRT. So here nRT, integrating this P from V1 to V2, we will get, replacing P is equal to nRT by V, we will get 1 by V dV. So just after integrating we will get nRT log of base E exponential V2 by V1. So this is the work done by the gas in the isothermal process, or the supplied heat energy, or the supplied heat energy, or the work done by the gas for the isothermal process. So this is the work done in the isothermal process. So if you like this video, then like, share it with your friends, and if you have any question, then comment me.